Hey guys, welcome back to Golang tutorials. This is Lodese. So today we are going to look on to one of the important topics in Go, that's concurrent. So what's concurrency? We might have heard this term a lot with the Go programmers. They are referring to concurrent model and what it should be. So this is a really interesting topic. So we'll just go through a classical program to understand this. So my problem is I have a video editor, some video processor, and I process video, I get some images for a thumbnail of the video, and I then compress it. So look at this is the image that I found from the video. Now I compressed it. Now it became smaller image. Actually when you compress it won't look like image, it's a compressed file, but for sake of representation I put something like this. So it took a minute for compressing 700 KB file. Okay, it's not that good, because you can think if you make a service, your service taken around minute to compress 700 KB file, maybe your users might not be that happy. Like they upload a video and they have to wait for a day to get the word functionality done. So they might not be happy. So maybe you have to break down. You don't need not process the entire file. You can break the file image into chunks and compress it. But if you break it 4 parts, maybe it might take 1/4 of a minute. Okay, that's not that bad. We reduce the time. So but if we can put it more, like if we put it something like we make 16 chunks, maybe it take in 1/16 of a minute. Okay, that's really good, because as per our earlier usage it was a minute, while taking 1/16 of a minute. That's good. So how it can be done in Go, that's what we are looking today. So what we want to do is we will make a file, we'll save it. So cc concurrent.go. so we'll say package main. So this is our main file. So we'll make a mock functionality, something like from process image. So it will take 2 arguments, one the number corresponding to this chunk, and another one which corresponding to the total number of chunks. Okay, so n and c both are integers. What it's going to do is we will run a for loop. I equal to 0 and I starts, we will put as some arbitrary number divided by number of chunks. Okay, so as number of chunks increases, this function will take less time to process a chunk. This is because you can see as number of chunks increases, the total number of pixels that need to be processed in a single chunk decreases effectively, isn't it? So we are for the same principle. So suppose I am saying I am starting to process the chunk, print line, so starting, oh my bad, starting to process what our end. Okay, maybe the ith portion of the nth chunk, ith portion of nth chunk. Okay, so what we're gonna do is we put a random time interval in between this. So we set rt random time equal to time dot duration. So what we will do is we'll put some duration here. We will use a rand function and get an integer number, maybe something like 100 by number of chunks. Maybe we can process it like we'll keep it something more interesting. We'll put something like n. Okay, something so it might get interesting. Maybe I will put something. Okay, maybe towards the starting it might take more time, and towards the end it might get done so fast. Like, just interesting, making it interesting, nothing more. So what we'll do is we'll do a time dot, okay, time dot sleep. So what we'll do is time dot millisecond start our random time. We'll sleep till that time, then that's our whole process. It will start processing it, and it will sleep for some time, then process each pixel. So that's it. So we got a working real scenario. We'll go for the main function. Okay, so what we'll do is we'll first define a chunks variable which carries the number of chunks it will be done. So basically we have 4 chunks at start. We assume 4 chunks. Maybe there's no chunks, it's just 1 chunk. Okay, now we have to use it for I equal to 0 and I less than chunks I plus plus, and we'll run this process. So we'll just do the classical way. We are not going for the concurrent model, we are just passing this thing. So I plus 1, we have to pass I plus 1 because as you guys know, if we put I pass I here, we get a 0 variable here, so we have to pass I plus 1 and chunks. So, and we will say we finish the process at something like this. Print line finish the nth process at time dot now. So now finished it. Okay, so we run it. We'll look what happens. Hope you don't run into much trouble. Okay, we will see. Okay, we started the process. It's taking time. Okay, so the process started at okay, I didn't start the marking time. Okay, we say starting the process fmt dot print line, we say starting at time dot now. So we do something like this. We started the process, it's running and it's running, we keep on running. So it started at 27th second of 26th minute. So it ended at 33rd second of 26 minutes. So it took around 6 seconds. Okay, 6 seconds round for processing a file, the image file. So how we going to do it in the Go concurrent way? So we put an Go keyword here and make the function run. That's all. But we'll sure run into a glitch. Let's see what happens. Okay, go run this. The process started and nothing. This is something that we ran into. Yes, that's it. That's the functionality of Go. That's like a feature. So what happens is we started the process, we started running the function concurrently, but the problem is the function ended right here. So the function concurrent functions that started running from this function will end here, nothing more. Once the function ends, all the processes started from here will be destroyed. So what we had to do, we had to wait till all this process has to end. So what we will do some dummy character, we take a dummy string and we'll do is we'll scan it, scan line and dummy. So now we can run this. It started the process at that time. Maybe I guess it should take something similar. Okay, it started around 9:0. Started around 28:09 and it took around 28:15, maybe, right? It took around 6 minutes, 6 seconds. Same time, if we increase the chunks, maybe by 4 or 16. So what happens? Okay, it just, whoa, it's just finished. It took around, it started at 2840 and 2840, maybe this took a second. What if you don't go for the concurrent model? Let's try it out. Okay. Okay, so it started at 2859 and it 2901. So it took around 2 seconds, while the other one just finished it right away. So we got some benefits of the concurrent model. We just finished things so early, like so run it. We just finished 29, 26, and where was it? And it is 29, 26 and 29, 26. The same second as we finished stuff. So basically, we found that concurrent model, we can run functions concurrently. But the necessary thing that you need to understand is concurrency doesn't mean parallelism. Because if you look at this, you can see what was that? So process of fifth process started here and it processed the first chunk only here, but while the first chunk has processed its 7th pixel at this time, while the second chunk did process the 7th pixel at this time. So basically it should have been first chunk processing the first portion, then the second chunk processing the second portion, the first portion of the second chunk, and it should have been that order, but it's not meant in that order. It means these functions are running independently. They are not running parallel, they are just running independently. It's like we can say something like this. Okay, look at this. We have an image. The first chunk arrived at the first second, and the second chunks, means for second and third chunks, arrived at the next interval. After some interval they arrived, after some another chunk arrived, maybe 4 chunks did arrive after at the 4th instant. So it's like they are ready to work. These functions are ready to work in a real world environment. They can run independently. So if you have multi-core processors, they can run parallelly also. But at the same time, concurrency necessarily means that they can run independently, like they can simulate the real world scenario. So we have processing image, but what's the fun if this processing image can't communicate its data to another functions? Like after processing, we might need to process the, after some, maybe we process the a chunk and we need to further process for some other reasons, maybe something like, we're not sure, maybe some other like we need to transcode the compressed image, maybe something like that, maybe some stuff like that. So maybe we are doing after process, we have a function like that. But how we gonna communicate, how the process image gonna communicate its data to after process? We can't run after process from each and every process image, because like it would be a mess. Like we have 16 chunks, so there will be 16 instances of after process, which is not that cool. So what we'll do is we'll keep only one instance of process. That will be a go routine. Okay, that's a concurrent go routine, and all the process image will communicate its data to the process, because after process it won't take much time. Like its cost, CPU cost is much less. So what it does is it will get all the data from all the go routines that have run from process image. So it will collect those data and run it by itself. So for this function go routines to communicate with each other, they have to use channels. So basically channel is like a medium, as its name suggests, through which go routines communicate. So basically, you know what is a go routine. Go routine is a function that we run using this go command, like this. This is a go routine. So this is a concurrent this function running in a concurrent model. Like in concurrent model we use go routines as the term. So this is a go routine. We have a go routine here, and it will communicate to this go routine using a channel. So what is a channel? So we say it's a channel, communicating channel. We initialize a channel something like using channel keyword. So we use a string channel to communicate. So how we going to use it? We also use a cc chat string. Okay, we say after process we run this, go after process cc. Okay, we also give the same cc to our process image. So what this also does is it will pass the same thing here. So both of them using the same cc. So if you want Go routines to communicate with each other, you give them same channels, and also make sure the channels doesn't get exited. Like there are chances I have often run into problems like that, where I initialize some channels in a function and accidentally I I don't make sure those functions do exist till all the process are over. Like I just exit the function due to some reasons, and my Go routines which were depending upon the channels that were initialized from this particular function were terminated. Because this function got terminated, obviously the channels that were created from this function will be terminated. So the other Go routines which were depending upon these channels will not work. They will crash, they will go to deadlock. So basically we have to do something like this. So how we'll communicate now? What we will do is we use a for. Okay, this is the normal generic way that we use to communicate. So we will say it's an out equal to cc. So this is the way it will use this operator to receive data from a channel. Okay, and what it does is out dot println out, and it came at a specific time, like time dot now. What we want to do is we'll provide, like we'll pass the data to channel using this operator. Okay, now we'll use same, we'll string convert and to integer to string. Okay, that's it. So this is the way we gonna pass the data after processing, and it will print it has processed it. So what happens here is till this cc dumps a value, the for loop, like it will wait here till the cc dumps a value into OU, output variable, and it prints it. So this basically that's what we are doing. So we can run it. Okay, just run it. So it just function as we thought. This like the earlier functionality has came like after processing, we gave it to after process. So what happens if we mess with this cc, like if we use the cc and terminate it? So you can try it out. Boom. Look, we fell into the deadlock because basically this function which was playing with this cc, just cc's scope did expire, and basically there were no cc to communicate, and it went into deadlock. So you guys make sure if you are playing with channels, like obviously you should play with channels. So when you are playing with channels, make sure you use the Go routines properly. So now we have functions which communicate with each other through channels. So we have Go routines which communicate with each channels. So we need something like we need to put some we might need, after processing the images, maybe we need to pass it to the we might we have processed the images. Now maybe some of the videos will be processed, so we have to accumulate those functionalities also. So in after process we need to look out for something like a multiplexer. Maybe after we have a processing video function here. Okay, okay, process video. Okay, as of now I will use the same dummy function. Okay. Here instead of cc I will put something like cv, which is also make channel string, and I will pass cv in here. Okay, cv. So what we will do is we can use select. Okay, select is the keyword that can be utilized for this, like it's more like a switch case, but in here we use the channels. Okay, select case, this case. Okay, okay, we just put here and break, or maybe case ou equal to cv, and we put something like this, cv, and we'll put something like this, image, and so it's video. What was that? Okay, okay, and we missed a operator here. Okay, so basically it will, this after process will process basically the image and video. So let's see how does that work. Well, let's go here. Okay, goes here. So I missed the video here. I guess I should put the video here. Okay, so we can see it now receives stuff from video as well as image. So basically our different Go routines can now communicate with the after process with the single instance of after process. So this is what we are doing. So in your day-to-day programming with a concurrent model, you will be using something like timeouts. You can use instead of this process view, you can use some timeouts. Maybe you calculate some timeouts and put, like, if you have gone through that much timeout, you exit the functionality. Like you see that you have taken too much time to process, so you end the process and say timed out, please try after some time. You can do some stuff like that. So basically, if you use after process, like it's like a multiplexer function. So you use one multiplexer function, but it will get the communications from different similar Go routines and multiplex them and giving them combined output. Okay, this is the basic stuff about Go routines and concurrency model. So I guess you guys enjoyed it. So if you have any queries, please comment below in the comment section and let me know. Okay guys, that's all for today. Thanks, love and peace.